Welcome to solverfy.
Okay, we've been shown a starting material, which is a diketone, and we've been told that when we react that with sodium methoxide and methanol, that we generate a so-called enone. All right, and so if you can't see this, if I color code things, this carbon I will color code as blue in our product, and this carbon I will color code as red in our product. All right, so hopefully you can see how this is a aldol dehydration to give the enone. And so where then is our intermediate, which would be produced during this reaction? Well, recall that we can always determine that, like we know generally that this reaction takes place by a carbanion being created on the alpha carbon of one ketone, which will, or aldehyde, which will then attack the carbonyl carbon of a second carbonyl. And in the case of aldol dehydrations, we have it such that the carbon who goes on to take place in a carbon-carbon double bond is the carbon that was attacked by the carbanion. That is to say that because this carbon in blue is going to become part of this carbon-carbon double bond, and we're going to lose this carbonyl, we know that is the carbon that was attacked by the carbanion on a different carbon, the alpha carbon to our other ketone. Well, our other ketone is the one that I have labeled red on the carbon. So then the answer is, which of these alpha carbons was converted into a carbanion to attack the blue carbon, right? Well, what you may notice is that if it were the one on the left, which I'll call alpha, just be a little more clear, I'll call that one alpha and this one alpha prime. If indeed alpha was turned into a carbanion which attacked the blue carbonyl carbon, then we would have a 1, 2, 3-membered ring. If instead alpha prime was converted to a carbanion which attacked the blue carbon, then we would expect a 1, 2, 3, 4, 5-membered ring to form. And in fact, that is what we have, a 5-membered ring. So we know then that alpha prime was deprotonated to form a carbanion, and that is precisely the intermediate that they are hoping us to find. It is the deprotonated form of this molecule. Like so, which is answer E.